at this point, we've completed our design in EDA Playground. And next, what you'll need to do is export those design files and the test bench files to a sources directory under your Lab2 for your box folder. Okay, so from there, we can import these files into Vivado. So let's create a new project. Okay, so it brings up this wizard to walk you through this process. You choose the directory. I have set this up in my box folder as Lab2. All right. We do RTL project, don't specify the sources at this time. Then we choose the boards tab, search for basis 3. Click next. Now we've established the target board and we're creating that project. Okay, so this takes a little while. And then what we have coming back is a place where we can import the sources. All right. So give this a second. Okay, from here, we're ready to import our design sources. So I click on design sources, hit the plus button. You could also do it here. And so I want these to map into the right place in Vivado, so I'm cognizant of what type of sources I'm putting in. So hit next. We're going to add files. I go to my Lab2. I've set these up in a sources directory, and then you need to know which ones are the design files. So Boolean 1, Boolean 2. I'm going to hold down the Control key. Boolean 1, Boolean 2. We don't need design.sv because that just has the include statements. We need Lab2 top. We need the wrapper. We need the multiplexer. We don't need the test benches for this step. All right, so we've left out design.sv because it just has the includes and all the other test benches. All right, so that's good. We hit OK and finish that. Then we're going to add in the simulation sources. So I'll make sure that radio button's selected for simulation sources. And now I add the test benches. That's why I named them descriptively with the TB so we can tell what they are. And we have the 3 test benches, and I don't need testbench.sv because it just has the include files. So leave that off. And we add these files and finish that. Okay, then we know that we're going to target this design for the boards. So let's go ahead and add the constraint files and add files for that. And I'm going to browse because I've downloaded these before for Lab 1, constraint files. And for this particular lab, we're just needing the LEDs and the switches. We don't need the other constraint files because we're not using those signals. Okay, so at this point, everything is set up. And remember, the point that we're trying to make on this one is we're looking at the simulation results. Okay, it's important to be able to make sure your circuit's working because it's too hard to debug on the board itself. All right, so we try to do this in pieces. All right, so let's first look at Boolean 1 and notice Lab2 wrapper is in a bold type because it's currently selected as the simulation source. Okay, so the vernacular for this Vivado is what is going to be the top for your simulation. Well, I want to look at the modules first before I want to make sure each module is working before I put all of them together into the total design. So let's take a look, and there's no include files like you did with EDA Playground. You have to right click and then set as top. All right, so when I do that, it'll update the hierarchy, and now Boolean 1 is in bold, and I can run the simulation from there. Okay. So I run that, and it pops up a window with both the test bench and the waveforms that are generated from that test bench. So let's give this a second. Okay, so there that is, and here's the test bench that we used, and let's see. From here, I can click on Untitled. I can break this out if I want it to be larger. Resize this to how I want it. Then hit the auto scale. Okay. I don't really need this signal. I think this is confusing, so you can delete that. That was the integer that was defined in the test bench. Okay, so there we go. We have the simulation results. Now, Vivado has a lot more options, and so one of the things you can do is you can select these 3 lines, and I want you to do this. Select those 3 lines, right-click, and then we're going to make a virtual bus. Okay, so that's putting these together, and so we can label that however we want. So maybe we would just say ABC. Let me get rid of this other stuff. ABC. Okay, so you see from here, this gives you the binary value, the decimal value of the binary code that shows up in ABC. So if ABC is 000, you get the 0 here. If it's 001, you get the 1 here. All right. And so you can right click on this and change that radix to be binary. All right. And so it actually shows that binary code. All right. Or you could make it show everything in hex. All right. So from this point, what I'd like you to do is take a screenshot of Boolean 1. And remember, I don't know, several people had trouble. If you use the keyboard shortcut for the screenshot, the lab computers sometimes just choke on that, and it crashes and doesn't run correctly, and you'll get a problem with importing that screenshot. So one thing to do is you can search for the snippet tool, and if you run it from here, rather than the shortcut key, things tend to go a little bit smoother. Okay, so that's just a tip that we ran into with Lab 1, and it's happened in other semesters as well. Okay, so that's one of the test benches. All right, so let's close that. Let's close this whole simulation. We don't need to keep that waveform. Let's close this, and let's go and run the Boolean 2 simulation. All right, so what would you do? If you want to run the Boolean 2 simulation, you right click, set that as the top, run the simulation. Okay, so as before, you can click on the tab that gives you the results. You can break this out, resize it the way you want it, auto scale it. Okay, remember we had this extra delay that was in here set up for that simulation. You could modify that with the test bench, but this is fine. Let's bus up the answer here. So right click, select the signals WXY, right click, create a new virtual bus, and that we could label that WXY. All right, and then you can set the radix however you want. All right, so radix binary or radix hex. Sometimes, you do a virtual bus like this and the bits tend to be in the reverse order. And so notice there's an option of reversing the bit order so you don't have to relabel things on the screen. Okay, so I lost that labeling, WXY. All right, so that shows us the second Boolean function. You would compare that to your expected results table and make sure that function is implemented correctly. All right, let's discard these. Let's close this simulation. Okay, and the next thing I want to do is let's do a simulation of the top. Okay. All right, so the top test bench. Lab2 wrapper shows up in here because that's part of the design process. Okay, so there's not a test bench for the wrapper itself because we assume that part's going to go smoothly. And so let's go ahead and set this as the top. All right, so you see that it's in bold. You're ready to run the simulation. Okay, and this result's a little more complicated because we had more things going on, so we can separate this out again. All right, auto scale it. All right, and we see the input X was already vectorized, so I didn't have to make the virtual bus. It came in naturally. That's why I did it that way. And this radix is already set to be hex. All right, and notice it goes through the input combinations twice. All right, one for when the select line is a 0, so right here. Notice when you click here, I click and it shows the value of everything lined up in this yellow cursor. So right here, this yellow cursor goes through the X vector being 1, the select line being 0, and F out being 1. So it's pretty convenient. You can select over here and check all these values one by one. All right, but the point is it goes through 0 through 7 once with the select line 0, and then it goes through 0 through 7 a second time with the select line being 1. And so you get both Boolean functions showing up as an output. You can check that against your ERT table and make sure things are working the way you would expect them to work. All right, so one thing that's different here is this. If you see something in red, that means that signal was not defined at this point within the simulation. So you go back and look at the test bench and you could debug why that would be the case. But that's for this integer definition, which is not super relevant for what we're doing anyway. So let's go ahead and move this off the screen. Let's delete this. And I just wanted to show you the red just means that that particular variable was not defined at that point within the simulation. Okay, so now I have this the way I want. I can use this screen snippet tool to get a screenshot for that. So I'm going to want screenshots for all 3 simulations for your lab report. All right, so that's the test bench stuff. That's the new thing that I want to emphasize for Lab 2, but we also want to practice the things that we did for Lab 1. So that's why I had you write your own top test bench and the top design file and the wrapper file. All right, so hopefully you're keeping that straight in your head about what each of these things do. All right, so from there, we're ready to close out of the simulation altogether. And we want to now make our design, we're happy with how it's working. Now we want to make our design go to the board. So that just means the regular flow where you next run the synthesis, then you run the implementation, you generate the bit stream, connect, and program the device like we did in Lab 1. All right, I think, my experience has been once you've gone through this a couple of times, people get pretty fast at working through the workflow for actually moving the design onto the board. All right, so from there, what you would want to do is check your hardware operation against your ERT table and then get the results signed off by me, and you'll be done with Lab 2, except for the report writing. All right, and so the report writing, you again use the LaTeX template, put the screenshots in, and look at the template for other information that needs to go into your lab report. And then remember, LaTeX generates a PDF file. You don't have to save it as a PDF. It's already generated as a PDF. Upload that PDF to Canvas and you'll be done with Lab 2.